Third grade worksheet lesson 24. List the possible outcomes for each experiment. So for number 1, we have a dice, and a dice has 6 sides, and on each side is a number from 1 through 6. So if we roll this dice, there's going to be an equal chance for each of them to come up. So that means that there's a 1 in 6 chance for a 1, a 2, 3, 4, 5, and a 6. Number 2, we have a color wheel and it has 6 colors: red, orange, yellow, green, blue, purple. And when we spin this arrow, there's an equal chance for each of them to be selected. So this is also kind of the same as a dice, except they're colors. So this is 1 in 6 chance for a red, orange, yellow, green, blue, and purple. Let's move on. Number 3. Looks like we have a bag and it has 2 blue squares, 4 red squares, and 3 green squares. So the chance of getting a blue square would be 2, because there's 2 blue squares, in however many total squares are in the bag. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 squares in total. So the chance of getting a blue square would be 2 in 9. So 2 in 9 chance for a blue. And since there's 4 red squares, it's a 4 in 9 chance for a red. And finally, since there's 3 green squares, it's a 3 in 9 chance, or 1 in 3 chance for a green. Tell whether each event is possible, certain, or impossible. Number 1, if you add 2 one-digit numbers, the sum will be 19. Let's look at what happens when we add the 2 biggest one-digit numbers, which is 9. So 9 plus 9 is equal to 18. So if 9 is the greatest one-digit number, that means this is the greatest sum of one-digit numbers, of 2 one-digit numbers. That means this is impossible. We can't ever go above 19 with just one-digit numbers. Number 2, rolling a 6-sided die and getting a 5 at least 5 times. We know that getting a 5 one time is a 1 in 6 chance. So the next time would also be a 1 in 6 chance. If you did it 5 times, there would be a really small chance, but it'd still work. So this is possible. Number 3, flipping a coin 100 times and getting at least 5 heads. Now, as you know, flipping a coin, there's a 1 in 2 chance of getting a heads or a tails, because there's 2 sides. Now, this one says that if we flip a coin 100 times, is it possible to get at least 5 heads? And that's definitely possible, but it's not certain, because there's always a slim, very small chance for us not to get at least 5 heads. It's a very small chance, but there's still a possibility. That's why it is just possible, not certain. Certain would be 100% possible, or 100%. Certain would be 100% sure. Let's get number 4. A box containing 100 pennies. You choose a coin from the box and it is a penny. Well, since every coin in the box is a penny, that means that this is a guaranteed penny. So this is certain, because we're 100% sure of the outcome. Look at the line plot and answer the following questions. So we have a dot plot of temperatures. Number 1, tell what you would predict for the next day's temperature and explain. So if we look at the plot, we see that the 60s are the ones with the most dots. That means that the next temperature would probably be in around the 60s, because it has happened the most. Number 2, What if the temperature for 7 days in a row were 46, 48, 52, 55, 46, 48, and 47? What temperature would you predict for the next day? Explain. If we look at the temperatures for these days, we see that 1, 2, 3, 4, 5 of them are in the high 40s. So because most of them are in the high 40s, we would predict that the next temperature would be in the high 40s. So we would say in the high 40s because that is what most of the past temperatures were. Let's move on to the word problems. Number 1. The cafeteria has 3 types of sandwiches and 3 types of desserts. Joanne says that she can make 6 different combinations of sandwiches and dessert. Describe her error. So Joanne made a mistake in calculating the total number of combinations. Let's see what happens. So if it has 3 types of sandwiches, let's draw like 3 different shapes here. And 3 types of desserts. That means you can create 3 for each sandwich. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And so if you count the number of lines here, you get 9. Now this is the same thing as saying 3 times 3. So for each sandwich, there are 3 different desserts that you can choose. That's why the total number is actually 9 combinations, not 6. Number 2, Caleb and Matthew play a pattern game. Caleb says 3 and Matthew says 12. Caleb says 5 and Matthew says 20. Caleb says 4 and Matthew says 12. What does Matthew say when Caleb says 7? Write a rule for the pattern. So it looks like there's an error with this problem. This should say 16. And now we can see the pattern, because when Caleb says 3, Matthew says 12, we can see that 3 times 4 is equal to 12. 5 times 20 is equal to, or 5 times 4, sorry, is equal to 20. And 4 times 4 is equal to 16. So when Caleb says 7, it should be 7 times 4, which is 28. So Matthew is going to say 28.